So just to confirm, you can see my screen, right?
Yes, yes.
Perfect, perfect. Okay, so thank you everyone for joining us in today's webinar that is being organized with our distributor in Middle East and Africa, Scope Middle East. And I hope this short webinar will be informative to you. Please, as David said, feel free to ask any question over the chat, and I'll make sure at the end of the webinar to have a discussion over the questions that are being received. So in today's webinar, we are going to speak about how we, from Stormshield side, have changed the game in OT cybersecurity. And this is, in fact, what we are saying. We are going beyond the ordinary approach. Although that we are going to have a little bit of deep dive, technical dive into the threats of ICS and SCADA systems in OT security in general, but it will be brief due to the time restriction. So just trying to highlight some facts, and we'll try also to be direct to the point, and we'll try my best not to bore you over this the next 45 minutes. So my name is Al-Qurashi, and I am the Business Development Manager of Middle East and Africa of Stormshield, and I'm also an OT subject matter expert. And you can see my contact details here. Feel free to contact me anytime. So in today's webinar, we are going to cover 5 important points. We will start from the OT cyber threats. We'll have a very, I wouldn't say high level, because we will mention some technical stuff, but just we'll take some overview about the OT cyber threats. We'll speak about the matter of trust. That is really important. And then about the deep packet inspection, the DPI. Following to that, we'll speak about the performance, and in the OT world where the time is a very critical factor. And also, finally, we'll speak about the next generation firewall capabilities and the integration within the OT systems in general, which is, again, a very challenging point. Starting from the OT cyber threats, it's important to take a look about the ICS architecture. Normally, this is a logical design or logical separation of different level of decision or functional level. So usually you will see from level 0, 1, 2, 3, 4. And level 0 normally refers to the physical part, which is actually the physical processes in terms of field input, output devices, sensors, and all this stuff. On the level 1, we have kind of the the regulation and automation. Normally, it's the controller LAN, and normally where we see the field logic and control. On level 2, we have the creation of process orders, for example, which is normally we have the local HMI or the remote SCADA. And we also find some historian data, like kind of archiving the information coming from the system. We have at level 3 the management and logs. So normally the operation management is operating here. It has like the control center, the application servers, we'll find them here. And on level 4, we have the enterprise zone. In the enterprise zone, where we have the finance, accounting, logistics, ERP, some web application, maybe Active Directory. And on top of that, we have the IT connected to the internet, or like would say the internet DMZ. Another look at the Purdue Reference for the security logical separation of levels according to its functionality. So this is again another look. So as you can see, at low we see processes, and we also see the safety instrumented system in parallel, where both they have their own sensors, their own actuators, and normally they are connected to level 1 to the brain. The brain normally is coming from the PLC or the RTU. Either both of them, they have the program that is going to be executed, and they are managing directly connected to these processes and directly managing them. On level 2, as we said, we have the remote SCADA and the local HMIs and some applications, including the historian or kind of an archiving of all the tags and all the state of different processes. And as you can see also in level 3, level 4, there are some different examples. Sometimes you could find like a jump server at level 3 to provide a remote access. And as you can see, this is the different levels of the OT. Now, in order to have a little bit of understanding, if we want to secure something, we always repeat the same sentence that's saying, you can't protect what you don't know. So it's so essential and important to understand what do you have, what threats are associated with what you do have, and then you can see how you can going to secure them. So basically, if you go to level 0, for example, you will see that there are many different types of threats. Normally at this level, there is no actually IP or Ethernet except in a very exceptional cases. But in general, all the input-output, they are carrying digital and analog information, and they are directly connected with the PLCs and RTUs. And the general threats at this stage normally could be something like physical access, could cause a threat, connection loss, or maybe a power outage. If it receives a wrong command, for example, to the actuator, it might lead to a disaster. Failure of input device, for example, a sensor, could also again lead to disaster. And visibility is normally a big challenge. And to be honest, at this stage, normally the next generation firewalls, they don't have much to add at this kind of protection. So, but it's important to know that this is actually the way it is. Now going to level 1, where we have in level 1, as we said, the RTUs and PLCs, and we have a communication between two different levels. The threats, if we look at an example of the threat modeling, such as the stride threats, you have to take a look. And of course, just I want to highlight one point. Whatever we are mentioning here, we're just taking some examples, because we insist on the fact that every operation and every industry, every vertical is unique. So at some cases, the risk level could be definitely different, but this is just an example, so you can understand what you need to do from your side. Now, from the threats, spoofing identity could be a high risk at this level. Tampering could be high risk. Repudiation also a high risk. Maybe information disclosure is not a risk at all, because just imagine that at this stage, like if somebody see what the command you are sending to the sensor or receiving, it will not really have any commercial effect if this information has been disclosed. Denial of service is again a big risk. And elevation of a privilege maybe is not really important at this stage, because actually it comes in the next slide when we say that these PLCs are insecure by design, and this is a very important subject that we want to highlight. So going back again to the examples, if you look at general threats, we said that physical power outage things, it's not something that the role of the DPI or the next generation firewalls to secure, but it's very essential and important to know that at this level, it's insecure by design. And it's when we speak about the vulnerabilities, we have to understand, and I have actually heard this many times in the community of OT world and ICS world, is that actually the PLC and RTUs are not really secure by design, which means normally if you are trying to if there is a vulnerability in a system, in a server, or any service that is being published, somebody could find an exploit to hack into this system using this vulnerability, and eventually they could do for one purpose only, to maintain access, and following to that they can execute their own payloads or execute their own activities they want to do. The problem about RTUs and PLCs, the majority of them by design, there is actually no authentication. And in fact, the moment you have a direct access to one of them, it means you have a full access to it. So actually you don't need to worry about vulnerabilities at this stage, because it's already insecure. Anyone who has access can do anything, so you don't need to exploit in order to do the intention you're planning to do. But actually, as long as you got access, that's it. That's why they are insecure by design. And this is one of the things we are addressing, which will be, this is actually the subject of today's webinar, how we are addressing such challenges and such risks. A wrong configuration could lead again to a disaster. This is something also we are providing a full protection to. They are very sensitive, which means that a very simple port scan could lead to crashing the PLC. Imagine a device, and it's running for long duration, and I mean like years. and they are very sensitive, and the moment you touch them, it will cause a crash, and it happens many times. That's why it's not really the good approach mostly to be to perform some active reconnaissance inside this level. It's mostly a passive way. That's the way that you can achieve and collect information about the network that you have. Visibility is a big challenge, yes, and it's something also we are providing an answer to. And we have to remember, the moment you have a device that is connected to IP Ethernet network, it's beside being subjected to the typical OT threats and the new OT threats, not only typical ones, but also it's subjected to everything that is coming from the IT threats as well. So this means that when you need to provide a protection, okay, you should be focused on the part of the industrial security protection to your system, but at the same time, as long as it's connected, it means that you need also to make sure that you have the protection from the IT world as well. So here we can take some examples. The communication types at this level, normally the industrial protocols over IP. You can take examples like Modbus, S7, OPC UA, OPC DA. The standard IEC 61850 that has protocols such as the Goose and MMS and others, Profinet, and etc. And they are all read-write operations that are going on. Now, what Stormshield is providing, it's providing a very detailed filtering by user, MAC address, IP, protocol, port, time, service type, many details, reputation, and stuff. Operation detailed visibility that you can achieve. Vulnerability built-in passive scanner, so it doesn't influence anything, doesn't affect anything with the system. It can create a very good segmentation and secure zones in an easy way. The deep packet inspection has all the capability in terms of protocol conformity, whitelisting. We will speak about that in the DPI part. Protocol detailed filtering, layer 2 to layer 7 intrusion prevention, blacklisting the known attacks, and some custom signatures for a very specific purposes. And that's normally the approach that we are having. So if you go also, the last example in this reference, like if you go at level 2, so you will see that the threats might change, including, for example, information disclosure might become a medium risk at this stage. Elevation of privilege might become a high risk at this level. So, you know, it's different according to the level, according to the operation. And finally, also the same thing, you have to study the attacks, the threats that you have. So it's subjected to Ethernet IP industrial attack. That's what we are doing. It's subjected to illegal access attack. So that's what we are doing, and so forth. So the same thing when you look at the communication type at this level, you will find like industrial protocols over Ethernet IP. Remote access maybe is another thing that is provided here. Inventory archiving for the historian data as well. So again, on the right side, you can see all what Stormshield capabilities at this level as well. So the point that we are trying to highlight in this first part is that, yes, we know it's what we are saying is part from the risk-based analysis, but we insist on the fact you cannot secure what you don't know. So either ways, either you are performing, providing a third party to do a full analysis and consultation for your operation, but either ways, you have to do your homework. You have to identify all the assets and all types of communications that you have, and then you need to define the threats associated with them. And if it's within your plan to perform the risk-based analysis in order to find the right security control as the last step to secure your operation. And that's what we are trying to highlight here. And the last point I want to mention in this section, that every operation and every industry is unique. So there is nothing that works in one place that necessarily will work in another place. Okay, they all follow similar standards, but every operation is unique. That's very important. That's why it's always mandatory to do your homework. So that's for the OT cyber threats. If we want to move to another point, is the trust. Trust is not just a word. Trust, you know, it's not something that you can just easily be confident about something. So trust is a big word, in fact. And from our point of view, we wanted to be trusted. We wanted to go to the path to be like provide the confidence to our customers and make sure that they trust the technology that they have. They trust that we don't have any kind of, you know, leaked backdoors or things. And that's what we are trying to maintain. So that's why we went to the path of having and obtaining the highest European certification. So as you can see, we have the EU restricted and NATO certified. We have from common criteria EL3 plus and 4 plus, France Cybersecurity, for example, and we recently obtained from CCN in Spain. We have the first firewall to be qualified and approved, which is something very unique. So it increases the trust level in Stormshield, for example, in Spain and other European countries. First industrial firewall certified by CSPN from ANSI. And finally, it's also by default GDPR ready. And what does this mean? Sometimes we have also to know, you have also to know that it's not always about the logo that you obtain and that you have it on the data sheet or things, because sometimes it could be misleading. So when we went to the path of being trusted, we wanted to make sure that it's not just another logo that we have on the data sheet. So imagine, for example, with a common criteria, normally EL3 or 4, it's the publisher who define the target. So as a publisher, you define, okay, I want to test my firewall if it has the ability to do routing, for example, or it has the ability to do NATing. So then there will be an evaluation, and eventually you will get certified. Yes, you can do NAT, and you put the logo on the data sheet, and you say, okay, so I am common criteria EL3 plus or 4 plus certified, where in fact, although it's a security device, but you got the certification or something else. And when we went through the ANSI certification, for example, and until we to obtain the standard qualification and enhanced qualification, the difference here, for example, is that they define the target, they perform a deep test and evaluation, and then in the like a very difficult lab conditions that are being applied on the device, and including a source code review to make sure that we don't have backdoors, so it can be trusted in the European Union countries, for example. And this is so important. So then when we obtain such certification, it means that we have done a deep test in order to be trusted. It's not just, again, just another logo on the data sheet. And the point here also, since I mentioned something about backdoor, you know, it's something really challenging. Imagine that you are implementing a security control within your operation, and this security control was supposed to secure your operation. And for some reason, without speaking politics, but sometimes in certain types of I would say regulation, the security vendors has to provide backdoor to the government in some way or another. And if by chance this backdoor was leaked to the internet, to the underground net, and some hackers could get access to it, then eventually they can gain access to your security control, and it will be your vulnerability at that point, and it will be the highest risk for you, because at that point they can eliminate all the defenses that you have, and they can have a direct access to your network. That's why it's really important to make sure that the products has no backdoors. It's not about political issue, although that's in the OT world, most of the cyber attacks we see coming are actually the major driver for them is political conflict. But nevertheless, it's still the risk about it is that if this backdoor has been leaked somehow and it happened multiple times, and that's the risk we are trying to address here. So who we are as a Stormshield. Stormshield is coming actually originally from two French companies, Arcon, which was established in the year 2000, and NetAsk, which was established in the year 1998. Both were providing UTM and firewall and IPS originally. And over the years, they have both developed a very nice and good features and good security level and protection. In the year 2012 and 13, there was a full acquisition from Airbus, and they became both a wholly owned subsidiary of Airbus Cybersecurity. And there was the merge done between two companies to become one company. And in the year 2014, we launched the new brand name Stormshield. So Stormshield since 2014 is a one company, including all the previous integrated and merged companies, fully owned by Airbus. And we launched the three product lines that we have: network security, endpoint security, data security for both IT and OT. That's who we are, and that's where we are saying that we are trying to be the trusted security provider for our customers. Then we speak about the technology. We speak about the deep packet inspection, the DPI. It's so important to know, okay, so we claim at the beginning that we are going beyond the ordinary. We said at the beginning that how we change the game, how we are not following the traditional way of providing cybersecurity that they have actually failed in securing their operations. And the cases, especially for the customers, they know the volume of attacks that are happening and the volume of attacks that actually was successful. So in order to do this, we need to take a look about the approach in the market and what we are doing. Typically, the traditional signature-based IPS analysis, they have like a small percentage of protection based on the anomaly detection and things like that. But the majority of the protection is based actually on the signatures, because when you see there's a support for a certain industrial protocol, it's actually just another list of signature-based IPS for this protocol. So when it comes to the signature-based, it's so simple. When the packet arrives, that needs to be inspected. So it will be matched against a signature database. If it's known, it's matching something known. So then it will follow the policy. If it's allowed, it will pass. If it's not allowed, it will be blocked. And normally, if nothing is matching, it will pass. That's unfortunately the majority of the approach in the signature-based IPS. Now, when it comes to Stormshield, we are doing something entirely different. We are not relying basically on signatures. However, we still have some signatures, but it's a very minor part of what we are doing. In order to understand what we are doing the security, the deep packet inspection through different algorithms. And from these algorithms, one example is the first one you can see on top on the right is the plugin analyzer. Plugin analyzer is a full protocol conformity whitelisting check. So we perform a deep analysis, and in the next slide we'll take a deep example about it. And this is really helpful to like reduce the exposure and think from whitelisting point of view instead of blacklisting point of view. Anomaly detection is built in and has been developing for many years. We have been evolving on this factor, on this protection, and it's a full based on heuristic and statistical analysis that is being performed on the network, on the traffic, so we can, based on the behavior, identify if there's any suspicious activity or any malicious traffic that is coming. And then we have some selected patterns, that these selected patterns normally, if we are obliged by law to provide protection for certain CVEs, so that's why we had to create some signatures because we have to be in compliance. And most of the time we are using them for the part of the IT to provide like a protection for the application control. So for example, if you want to have control over the like button inside the Facebook, so that will require a signature. That's why for the applications, yes, we have signatures, but mostly it's not what we are doing from the security point of view. And also it has the vulnerability scanner and host reputation. This is a very nice passive work that is being done on the firewall. So we passively scan all the traffic passing through the firewall for vulnerabilities, for application, for operating system, for everything, and we build a full inventory view about what's inside the network, what are the applications, what are the operating systems, and if there is any vulnerability, you will see the full details about the vulnerability and you will receive the report so you can act accordingly. And also and it has no effect, by the way, on the performance, because it's passive, it's passively work and only works when there is no load on the resources. So there might be a delay of 20-30 seconds, but this doesn't affect anything related to the vulnerability scan. It's not an IPS, it's not a real time. That's why it doesn't impact the performance, and at the same time it's very efficient. And also we have the host reputation, where in case of host reputation, what we are doing is we are building a baselining per hosts. And so this baselining of the host of scoring and threshold is built according to the last 15 minutes activity of this host from different inputs, let's say antivirus, say IPS or something. So this is being recalculated every 15 minutes according to our own algorithm and according to the previous value. And then you have a score for every host inside your network, so you can restrict in the policy based on certain thresholds. So if the reputation of a host was beyond this value, so then another policy will automatically be applied, so you can directly take some remedy actions on top of that. This is an example on the plugin analyzer. Of course, I won't bore you with the details. Just to let you know that the example we are doing is that we are doing a deep algorithms, and this is a very high level. In reality, it's much more complex than that. So we have things included in the plugin analysis, where we like try to detect first of all what type of protocol it is. If it's associated with a service, it's fine. If it's not, then we have to perform an automated detection to know what type of protocol it is. If it's not matching, let's say for example, I have defined this rule to allow SMTP traffic, but then I'm receiving an HTTP traffic trying to be tunneled over the port 25. So this will be detected, and an alert, specific alert, will be saying that there is an invalid protocol on over port 25 coming, for example, HTTP, and will be blocked. And then after identifying the protocol, then it will go through the compliance. So it will go through the RFC compliance, the protocol standard compliance in terms of structure, field value, order. What do I expect in each value of the order? Which one is start, which one is the end? So it's a full compliance check on the protocol, and if it comes with a totally correct parameters, it's fine. If it's not coming with the correct parameters, then also will be reported. And following to that, it will check the internal detailed of this protocol. Let's say if it's an HTTP, so it will check the HTTP command if it's allowed or not. If it's a Modbus, it will check the function code if it's allowed or not. If it's whatever type of protocol, it will check. And the good thing about that is only when it's matching everything, it will pass. Other than that, it will not only be blocked, but you will get a detailed message including why it was not matching something and why it has been blocked, with the detailed information that is required. And this is a very high level view also about some protocols that we are providing a DPI protection for. You can see it's a full OT, so it includes the industrial part, the ICS, which is the DCS and SCADA, and also includes non-industrial protocols such as the building management system or health vertical or things. So all these protocols and others as well, we provide a DPACT inspection, a DPI for them in the way that has been explained to you. And then we go to the performance. In the performance, it's also an important factor, which is, it's a time critical operation. You can't afford delay, you can't afford latency, and that's why it's important to understand that when you select the right solution, you have to focus on this area. This area is very important. Performance, latency is really a big important factor. So the problem here is normally when you look at the specifications of different solutions, normally the focus normally is on the firewall side. So in the firewall, firewall, maybe the debate 20 years back was if the firewall is the security or not, but today it's not. Firewall is just looks up to layers 4 to transport layer, checks the port IP. That's all. It doesn't really do any DPACT inspection. So firewalls is essential. It's always good to reduce the exposure to only allow the ports and IPs that are supposed to be communicating. But on top of that, you need the DPI. DPI, what inspects inside the payload, inside the packet, and checks for the malicious and attacks. So if you want to measure the throughput, the performance that is required for you should not be based on the firewall, because you will see in the market this kind of bottleneck or paper filter effect, or some filter, I don't know what kind of filter it is, effect that you will see a huge drop in the performance when you switch from the firewall protection only to a DPI. And this is really risky. This is really not good, and it's something that has to be calculated in the time when you are selecting the right security control for you. In order to understand what we have difference in Stormshield point of view, why we have the performance is something really good, although that in sometimes when you compare some of our models with some other competitors, for example, you will see that they have a very high number in terms of firewall comparing to what we are doing. Sometimes not so much, in fact, but at least they can maintain a higher number than what we are offering. In order to understand this is like a comparison from the architecture point of view, and this is the analysis required, the analysis time that is required. So imagine this is, the higher it is, it's worse. It means like it takes more time to provide an analysis. So this is the latency included, and it's coming from the architecture itself. If you look at the left side, leftmost, you will see the hardware acceleration, the low frequency. Normally, these are the things that are like the application-specific integrated circuit. I think the ASIC-based. It's an acceleration using hardware, and normally they have the low frequency. The good point about these architectures is that they don't require a lot of time to load the driver, and they immediately work on the firewalling part because it's a hardware. It directly functions so immediately the firewall will start to work. There's no need to load operating system or whatsoever. That's why it has the minimum time required to perform the firewalling operation, and that's why they have much higher throughput normally when it comes to the firewalling. When you look on the middle, you will see the software technology high frequency. So this is normally, it has a high frequency processing. It's pretty much similar to what we are doing at Stormshield. However, only the software that is different. So the software technology, it will require to have the packet driver load. Normally it takes a longer time than the ASIC based. And then they require to load the operating system, and then they can start doing the firewalling. So that will add some latency, and that will add on top of that some delay. That's why the processing itself, the throughput itself, it will be on the firewall side less than typically the ASIC based. Going back, when we look at the IPS, when the moment we activate the IPS, the deep packet inspection, when it comes to the ASIC based, at that point on the left side, they need to load the operating system, and then they can search inside the IPS signatures and their anomaly detection or whatever they have. So that means they would require much longer time than the others at this stage. That's why their performance numbers, and this is something you can obviously see if you look at the specification, it hugely dropped from the very high throughput numbers coming from the firewall until the very low number coming on the IPS. So it's the opposite way, as you can see. And in the middle, when you look at the software technology, since the operating system was loading already and the firewalling is working already, the moment you activate the IPS, actually the delay that is required is much less, and that's why the software technology perform better performance than the ASIC based when it comes to the deep packet inspection. And then we go to the last example on the right side, which is Stormshield. Stormshield, in fact, it's software technology, but it's a bit unique software architecture. So we have done some kind of an acceleration using algorithms. So we need, of course, some time to load the packet driver at the beginning, but then we immediately work on the firewall and we immediately work on the IPS because we don't have an operating system. Actually, the operating system and the firewall and the IPS, they are all a single process. So all our components are integrated at the operating system level. So they act as if they are a single process. That's why we have quite like in the middle in terms of firewall throughput, but we have the fastest IPS throughput, and that's why this is something very obvious you can see when you look at normally in the specification of different products. And when it comes to the true performance comparisons, that's the things that we're trying to focus on. You know, you look from the left side, you have IPS connections. On the left, on the blue one is Stormshield. On the right side, you will see others, and this is a claim. It's not 100% accurate, but just to deliver the idea. When it comes to firewall connections, normally they are based on, you know, firewall doesn't require that much of processing. So the number of connections that we support is quite similar to number of connections that the other firewalls can support. When it comes to IPS throughput, normally we have a higher number. When it comes to firewall throughput, normally we may have a lower number. Now the point is, I want to highlight here is that we in Stormshield, we don't focus on the firewall's numbers. So you will see, for example, if you look at the IPS on the concurrent connections in our data sheet, for example, it's built and based, these benchmarks are based on the IPS, not on the firewall. So in fact, we don't show our firewall numbers, we show our IPS numbers because that's what really matters. That's why if you look and compare, you will maybe at the beginning you will see, okay, yeah, but you are a little bit less than the others. Yes, we are a little bit less than others, but you are comparing an IPS connections to firewall connections. So our firewall connections is much higher than that, but our IPS connections are way higher than what the others can support. And this is the important points to highlight in terms of performance. And the last word, the last part is the next generation firewall and the integration within the OT network. I know this sounds like a mess, and in fact it is. We see some approaches towards securing the operational technology is to go through an integrated components through an APIs. So you have some multiple components. Each one of them is good at a very certain functionality, and all together they can achieve a very high level of security and control, and it looks really attractive, which is good. But the problem is, and I don't want, like you can see these different components, a lot of things are there. And like sometimes you see that you need an OT IDS integrated in the network, and you need a firewall integrated also in the network, so they can both communicate, and they can both, one of them, because most of the firewalls, they cannot detect all types of industrial protocols, especially the protocols that are at the lower levels, like not low, I mean like the Ethernet protocols, not the IP protocols, such as Profinet or IEC 61850, the GUS and MMS. These protocols require, it's not an easy to create just simple signatures. That's why in these types of protocols, some vendors, they rely on another OT IDS provider, where they can scan, identify the things, and perform some anomaly detection and inform the firewall about the risk about certain connection, and then this firewall can block the connection. The problem here, and this is a true input coming from our customers, it's never been used. It is there, it is being deployed in this way, but nobody really today trusts this kind of integration, that one system decides on something and another system just to block the connection because of that. And another point is that you can't rely on the infrastructure you are securing actually to exchange your security control commands. So imagine like this link between both can be through a very simple DNS attack or DOS attack, or maybe a very basic and simple ARP spoof attack at this level. You can disconnect entirely all the communication between both of them, and then you lose this kind of control. And furthermore, there are a few questions that challenging this approach. Let's say that how to integrate all these components. Now, you know, if you want to achieve some kind of segmentation between different levels or between different components themselves, imagine that you want to implement all these equipments to secure something and create a segmentation. It's really complex. It's too much complex to achieve. Furthermore, furthermore about the latency. Latency is, there is an accumulated latency between different systems and communication over a network. That's also a very risky. How about management? So you need to manage all these solutions. How about training? So you need your team and staff to be trained in all these systems. The support, licensing, pricing, all these questions actually can prove that this is not the right approach. What we are doing on Stormshield is that we have a fully integrated components, fully harmonized components. They are all functioning at the kernel level. So you have the DPI, sorry, in terms of IPS and IDS. We have the conformity whitelisting check. We have the firewalling, anomaly detection, application control, and the possibility to create a very nice segmentation, baselining, and vulnerability scan. All of them are integrated into the kernel as a single process. So you don't, and we understand and cover all these industrial protocols without the need for another third party. However, okay, we provide an API. Yes, it's good. It's there, same as others, but we don't rely on others. We have the ability to do it, but we don't do it because we already have a sufficient protection as of today for what we are securing our customers. So the good thing is that they are harmonized components together, a very low latency because it's a single kernel. We provide the best security through all these techniques, and all of them are coming on a very unique firmware that can provide a really higher performance in terms of DPI. Another important point is that although that we have all these features, but imagine that we have a full logical separation in between what the features that you're going to use and how the device is going to be integrated. Which means normally if you deploy in most of the cases, and I'm sure most of you know that if you deploy this device in inline, transparent, for example, or on a bridge, I don't know what you call it, it will turn into an IDS. And of course, it cannot perform any routing functionality because it's layer 2. It's just providing some kind of an IDS detection only. Sometimes, you know, this port can work only as a WAN, this port can work only as a DMZ or as a LAN or something. So you are like, it's kind of strict. You don't have the freedom to choose what you want. And other times you may have a mixed environment, so you need to use the kind of a complex configuration like virtual routers or maybe virtual domains just to achieve kind of a segregation and provide a security for this complex network. When it comes to Stormshield, the good point about Stormshield is that deployment is totally isolated from what the features you are trying to use. Imagine that it can be inline, transparent, can be a fully routed environment, it can be a hybrid mix between both. So you can have whatever interface you want as a bridge, whatever interface you want as a routed, and you can create a bridge between one VLAN from one interface with another physical interface, and like the way you want. You just plug the port to whatever network it is. You just set the same configuration of it, of the same subnet, and that's it. Now that has nothing to do about the features. So it's still, although it's an inline transparent, it can do routing, it can do load balancing. Although it's inline, it can do a full IPS and IDS and full DPI, and all features can be working. So this is really nice. You can achieve the highest segmentation, the most possible segmentation easily without the need for a very complex configuration and to troubleshoot them. And we know that at the operation, normally it's really hard to have this high level of knowledge. So we are close to finish. So finally, we just to show you some examples. This is according to the functional level segregation. So Stormshield devices can be at the lower levels, can be at in between level 2 and 3, between level 3 and 4, and 4 and the IT and internet. And of course, depending on the capacity, you can choose the model. So maybe you'll need the rugged model at, normally at the PLC RTU level, and you can take the normal IT appliances or maybe virtual appliance or whatever. So this is how we can achieve that segmentation between different levels. However, within the same level itself, we can achieve the much more segmentation and isolation for every component by itself, so it can operate, work, be accessed according to the policy that you have set, and at the same time it's totally isolated and segregated by itself. So it's not just a segregation or a convergence point between IT and OT, which is important, and this is what we are doing actually, but at the same time, within the same level itself, its components can be totally isolated and separated using the flexible integration of Stormshield firewalls. And this is the products that we have today. So we have the rugged models, SNI 20, it's more for the electric part, SNI 40, another rugged model. We have the normal IT appliances from small, medium to high end. And we also have the virtual appliances that we support all these hypervisors. And all of them are coming on the same firmware, the same features, my friends. So you don't worry about like, okay, so this is, I need an industrial one to work on this one, or you will switch to another interface, another feature, another training, another what. No, it's the same feature, the same interface. The only difference is the capacity or the way of deployment that is being required. To wrap up, finally, next generation firewall features are built in on every Stormshield device. The standard license includes all these features. Of course, I will not go through all details, but I mean everything related to security, encryption, networking, filtering. You can see whatever you want. All of these are built in. So it comes by default, like with a full PKI, a full authentication, control over, bring your own devices, with everything. There are only few options that you can acquire. If you're looking, for example, for a certified IPsec VPN client, like by ANSI or by common criteria, then there is an optional one. However, the standard one works. If you want to upgrade from the standard antivirus to Kaspersky antivirus, then that's another option. If you want to support the industrial protocol on non-rugged models, because on rugged models by default, industrial protocols are there, but if non-rugged models, you need to purchase the option. And finally, the vulnerability scanner is another option. And if you want to have the advanced URL filtering, not the basic one that comes for free, you can also upgrade with the option. Last slide is about interactive visibility. So we have at Stormshield a built-in reports on the device itself. We have a built-in and integrated audit with a very nice search for all the logs, advanced search that you can go to the bottom of whatever you are looking for. It provides a very nice application operating system, bring your own device inventory. You have a direct access to help page. This is important. So you can see in these two examples, one of them is related to an alarm from the IPS. So this is on the, I think, OPC DA protocol. So you can just click on open help to see details. So you'll have a full help page showing all the details about this alarm. Or on the vulnerability as well, you can open the help page anytime. So it provides you with a full helpful page about all these type of alarms, of vulnerability, and how to the risk, and full report. In fact, you can easily search on keywords, and you have a very nice interactive view, which means you can take actions directly from the report. So you can modify an action from allow to block without the need to go directly to the configuration and modify it, or you can jump directly to the configuration to modify it. And that's all. I hope it was informative to you. And please, if you have a question, it's time.